So as I said, it's the light independent reactions where carbon dioxide is involved, okay? Now, where does that happen? That happens in the liquid part of the chloroplast, which is called the stroma. S-T-R-O-M-A. Now, some students get confused between the stroma, the liquid part of the chloroplast, and the stoma, which is the space between the gap in the stomatal apparatus. So just put an R in, and you've got stroma. And that's the liquid part of the chloroplast. And this is where the liquid part of the chloroplast is where the light independent reactions occur, sometimes called the Calvin cycle, after the guy who discovered it. Now, inputs to this are, of course, CO2, carbon dioxide. So this is where the carbon dioxide actually gets, as they say, fixed into sugars. And then another input are, for the light independent reactions, are these two outputs, ATP and NADPH. As I said, these are the temporary energy stores that are created to drive this reaction, the Calvin cycle. Okay. Now, another thing we like to put in at this stage is.
Can I just do something, John?
Yes, of course you can, Jeff.
Because it might be worthwhile just saying here lower energy, just to emphasise that. So at that stage, they're lower energy molecules.
They are, yes, and then they get
higher
yeah.
energy.
Because they've got these bonds here. The extra phosphorus and the hydrogen here are able to do work in reactions. So thanks for that, Jeff. So low energy here, and then they get charged up using light energy, as you will see in a while, into ATP and NADPH, which are used in the reaction here. Okay, now the other thing I usually mention, if I can find my pen, is there's a very important enzyme, which is apparently the most abundant protein in the world, and it's shortened to Rubisco. Like when enzymes, as you probably already heard, when enzymes do something, they actually name them after the substrate that they work on. Rubisco is ribulose bisphosphate, which is the substrate, and what it actually does then is it carboxylizes it, so it adds carbon to it, okay? And it can also do an oxygenase activity where it actually adds oxygen, which is wasteful under certain conditions, and we'll find out about that in another unit. But what we're focusing on here is the ribulose bisphosphate carboxylase activity, where this enzyme complex, as it is, binds the carbon dioxide, and it binds it to this 5-carbon sugar, ultimately to produce a 6-carbon sugar, which is sucrose. Okay, so in terms of then outputs, we have sugars, and these guys get used up, so they will be outputs as well, in terms of you get ADP plus a phosphorus and NADP plus a hydrogen, right? So those bonds have been broken down as the energy was used to drive these chemical reactions. Now the key about putting that in is that these guys are recycled back into the reactions, because there's only a finite amount of these chemicals, so they get reused all the time, recycled, the ultimate in recycling. Another thing that happens, although it's not in this equation, is there's new water created in the reaction. So we also get new water, so that produces water in the reactions, okay? So that is an overview of the actual inputs, the location where things occur, where the reactions occur, the inputs to those, and the outputs. And the key, I guess, is that within the chloroplast, it's all about being able to do reactions in various places in compartments. You've got the light is trapped, the light energy is trapped in the thylakoid membranes. It's converted, the light energy is converted into these energy stores here, right? So these guys, the light energy converts into ATP and NADPH, all right? Temporary chemical energy stores. An output is water, oxygen as a byproduct, because water is broken down. And then in the next reaction, which occurs in the stroma, which is the liquid part, we get the fixing, as they call it, fixing of carbon dioxide into the sugars. And we use these temporary energy stores from the light-dependent reaction using the enzyme Rubisco. And these guys drive that reaction to create sugars, high energy compound because of the bonds. And then these guys are outputs of that reaction, and they're recycled back into the light-dependent reactions, and we get new water, okay? Now, students will get confused. If you just learn this rote without really understanding it, and you're asked a question, you'll get confused as to where the CO2 happens, because this overall equation doesn't help you at all. It's almost like it all happens at once, but it doesn't, as we see. It's all in different places within the chloroplast organelle itself, and those places are really important for enabling the reactions to occur. And we'll see in more detail how we do produce, for instance, the actual ATP and NADPH from these guys using the light energy. Okay?